To get single sign-on, we are first going to outsource and centralize the credential database. Fewer password is a major plus for users. In some cases, we may not even need to know or remember who it is. Anonymous ID could be all we need. For example, a student or a professor wants to read an online magazine. The subscription was paid by the faculty IDP says, yes, they are from here, and the magazine publisher just shows the article. We want the identity details in a consistent, simple way. So let's do strings, away with SIDs, security identifiers, replaced by a role claim. Authentication method, just a string, which the application specifies before or receives after authentication, etc., etc. But all applications on all platforms, the same attributes. That is standardized interoperable code. Instead of doing all the configuration and API stuff in each application, we let the identity provider do that. If we do authorization ourselves in the application, then we typically use a unique ID and a lookup for the authorization data. But we can also let someone else provide that authorization data in a claim. For instance, a spending limit. The application doesn't need to worry exactly how the IDP authenticates the user. This allows for incremental improvements without the application having to be recoded, recompiled or reconfigured. So improvements of the IDP automatically go to all applications. So how would an application do that? Have you ever used Forms authentication? What does Forms authentication do? Indeed, it uses a redirect. That is what DubIF does too. In this case, we do not redirect to a local page in our application, but we simply redirect to the identity provider. The application would trust that IDP, of course. When the word trust is mentioned, then we all think, trust who and why? But this is nothing different from what we are used to. In Kerberos, we trusted the domain controller. Now we trust the IDP. It's just a different HTTP-based protocol. And of course, there is integrity protection, etc., etc. The trusted IDP will do the authentication and then presents the claims in a consistent way to all applications. Now we need to learn some new terms. Claim. That's an identity detail of the user, and the user is now called a subject. A detail like email, etc. Let's demystify this for once and for all. Let's be very practical. You can look at them as attribute value pairs. Here we have a SAML 1.1 token in the form as Microsoft likes it. We have an attribute name group and we have an attribute value, application 1 admins. If the attributes come from an LDAP directory, then the attribute value terminology is really LDAP attribute value. But the claim can of course come from any store. In this explanation, it is just a SAML token representation. In other tokens, it's slightly different of course. Security token is just a set of claims, a collection of claims, but signed by an issuer. In the SAML case, it is serialized in XML with an XML signature by the issuer. And an issuer is a component that has policies, rules, etc. and issues the security token. Applications trust these issuers and also verify the signature to check if it comes from a trusted issuer. The issuer can rely and trust another issuer to do the authentication. It just adds and resigns claims. A special issuer with a credential database is called an identity provider or IDP. It is an issuer too. Let's run through this logon and claims extraction scenario for an application with ADFS as an IDP. The user goes to the ADFS server to be authenticated. ADFS authenticates Marie and pulls the relevant attributes from the Active Directory. ADFS knows how to do transformation via rules like transform a group in AD, clerk, into a role, user. In this example, ADFS also queries a SQL Server for a spending limit and receives $250 as a limit. The claims are collected into a signed security token, and the user then presents this token to the application. As you can see, it is now transformed and enriched with a spending limit. Another transform that has taken place is leaving out the real name of Marie. It was transformed into an ID with the value TN5FXDW3, etc. This may enhance the privacy of Marie. A common way of doing this is adding a nonce and using an encryption key that is specific for the relying party. That way it remains the same over time, and the IDP could track and trace, but it is different for each relying party. Now let's take a look at real machines. We are here at our yellow machine. That's a server that we just use as a platform for our browser, and we are going to take a look at the expense application. We're at blank. Let's go into history, and we're going to the expense application. Now, the expense application needs authentication, so it will automatically redirect me to get authenticated. Enter, and there we are at the green issuer. That's our local issuer. We will log on with Marie with an identical password, and then we'll do sign in. This tool will be pretty quickly, and it will immediately go to the expense application. The expense application is on the same server, so it is green too. Here's our expense application. Here are the claims, department manager ID, spending limit, role, etc. We'll talk about this grid control with the contents, and here are the values of the claims. That's sales, spending limit, and here are the XSI type of the values. So this was outsourcing to a central issuer, not your application that does the authentication. But there's more, and that is federated authentication.